what do we do? This is really simple. I will make this one harder than it is. When we divide a polynomial by a monomial, what is our strategy?
Factor. No, you just split it up. Common denominator, you just
Split it up.
Yeah.
So that's not factoring. That means we're going to split it up. We're going to split the common denominator up. Split it into separate fractions. Good. So then each of these plus signs in the numerator
Before a cube divided by 4a.
is going to become, those are going to become the plus signs between the three separate fractions, right? So we end up with 4a cubed divided by 4a plus 8a squared over 4a plus 24a over 4a. Are there any values of a that we have to exclude? Zero. Yep, because there's only one factor in the denominator, one different factor that has a variable in it, and it's 4a. It shows up in all the denominators, so a can't equal 0. And now all we have to do is just simplify each one of these fractions separately. First one. What happens here? What do I get?
4a squared.
Not 4. A squared. What happens to the 4's?
They cancel.
Yeah, they cancel. 4 over 4 reduces to 1. A cubed over a is a squared. Next one. 2a. Good. 8 over 4 reduces to 2. A squared over a reduces to a.
6.
And 6. Yeah, the a's cancel and I just get 6. Easy, right? No big deal. Okay? All right, let's look at one long division problem. Just get one more of those in for practice. Okay, so what about this one then? We're going to put what goes?
Top goes inside. Okay.
Top goes inside. So tell me, what do I write inside then?
X for
X to the 4th.
plus 0 x cubed.
Good, because I skipped the x cubed term in my numerator, so I have to include that because I need a column for my x cubes, right?
Right.
So I get 0x cubed plus
6x squared.
X
Plus
squared plus 5x plus 26.
okay, what goes out front?
X squared plus 1.
There you go. Okay, so now when I do long division, now I've got to start this cycle going. There's 3 steps in each cycle. What are they? Divide, multiply, subtract. Divide, multiply, subtract. Okay, very good, very good. So let's see, what am I dividing first here?
X to the 4th divided by x squared.
Good, and I do that because I have the leading term inside divided by the leading term outside. So x to the 4th over x squared is what?
X squared.
X squared. So that's going to go in my x squared column. There's the division step. What's my multiplication step going to be?
X squared times
X
squared.
Is it
X squared times x squared.
x4 or is it 0x3?
Oh.
I got to do that, right?
Oh.
I have to multiply by whatever's out front. So x squared, I'm going to distribute then, right? X squared times x squared is
X to the 4th.
x to the 4th. X squared times 1.
Let's go.
X squared.
X squared, so that's going to go in my x squared column. So we divided, we multiplied, what's next?
Addition.
Subtract. How do I write that down?
Parentheses around the bottom.
Okay, I put parentheses around it,
Oh,
the
negative.
minus sign out front. Okay, and when I subtract, the x to the 4ths cancel, right? We know that. Okay, what about this? Now, let's talk about this for a second. The 0x cubed. So, I mean, do I bring that down?
Yeah.
I could, but why would I? Right? Because think about that.
0.
If I bring the 0x cubed down, the x to the 4ths are gone, right? So then that would mean if I did that, if I brought that down, I'm wasting a step then in a sense. Because then my leading term is going to be 0x cubed. So ask yourself, x squared times what is 0x cubed? But what is 0x cubed? 0, right? So x squared times what is going to give you 0? 0. So why would I want to put a plus 0 up there?
I don't know why you'd want
That doesn't do any good, right? I'm not going to put that in my answer anyways. I'm not going to just add a random plus 0 in there, right? So we don't do that. We don't bring the 0x cubed down. Think why the 0x cubed was there in the first place. It was there to create the x cubed column, which turns out we're never going to use, right? Because we never got any x cubes to subtract. So we just don't even bother with that x cubed. We just move on, right? Because we don't want a 0 coefficient for our leading term. That would be like saying when we wrote down our polynomial inside the division bracket, it would have been like putting a random 0x to the 5th out front. Well, we wouldn't do that, right? You don't start a polynomial with 0, okay? So then we just skip that one and we move on to the x squareds. 6x squared minus x squared is what? 5x squared. Okay, now if I had a 0 over here somewhere, I would still need to keep it because then it wouldn't be in front. It would be inside the polynomial, and I still need that 0 to keep that column consistent, right? But I don't have any inside the polynomial. That 0x cubed was outside the polynomial. It was in front, so I ignore it. Bring everything else down. So we completed a cycle. We divided, multiplied, and subtracted, right?
Do it again.
Okay, so Evan, now what am I dividing? I get started again.
5x squared.
Evan, what am I dividing? Evan, what am I dividing?
5x squared, 5x squared.
Yeah, by leading term inside, by leading term outside. So 5x squared divided by x squared is, everybody? 5. Good, so I'm going to put that in the constant column. I get a plus 5. Blake, what do I do with that? I divide it.
You divide it.
I already divided. I got 5. Now what do I do?
Oh, it's like you multiply it.
You multiply 5 by what?
X squared plus 1.
There you go, by what's out front. So if I multiply this by what's out front, 5 times x squared plus 1 gives me what?
5x squared, it cancels out.
5x squared
And then plus 5.
plus 5. Okay. And now I subtract, so I'm going to put that whole thing in parentheses, subtract, the 5x squareds cancel. I bring down my 5x. 26 minus 5 is, okay, so I get plus 21. And Kendall, do I go again? I don't, you're right. I stop. How do I know that I stop?
Exponents are bigger on the outside.
Yes. Now the power of x after subtracting is less than the power of x outside. So I can't do that. I'm done. That makes it my remainder. The other clue was right there, right? If I got if I got my remainder, not my remainder, God, I can't talk. If I got my constant, a constant 5 when I divided, well, look, the top of what I get on top of my division bracket is the polynomial part of my answer. Well, if I'm all the way down to the constant part of my polynomial, I got to be done. There's nowhere else to go, right? So that would have to be the last step, wouldn't it? Right? Either way you think about it, that's my remainder. And so now how do I write my answer?
Write the
X squared plus 5?
X squared plus 5, right? There's the polynomial part. So I get x squared plus 5. What about the
top
fraction
The
part?
remainder.
plus the top numbers.
Okay, so the remainder is 5x plus 21.
2.
Yeah, 5x
Plus 2. No, it is.
And what does that remain over?
original denominator.
Original denominator. X squared plus 1. So there's my answer. Okay, good. Give me thumbs. How we doing? Good. All right, so how come we had to use long division there? Why couldn't I have used the much easier
Because the
synthetic
X is
division?
squared.
Because the x is squared. Okay, give me thumbs on this one. Can I use synthetic division here?
Yes, sir.
I can because the bottom looks like x plus a number or x minus a number. It's x plus a number this time. So we would set this one up with our synthetic bracket. When I make my bracket, how many horizontal rows do I need room for inside my bracket? 2. Okay, what's the first row consist of?
Horizontal.
How many horizontal rows do I need?
Coefficients.
Coefficients. So what are my coefficients in order?
1, 4, 6, 3.
Okay, 3 is my constant, so what do I have to put under my bracket there?
Square.
Good, I put my remainder box. And now what number, you gotta be careful with this, what number goes out front?
You 1.
X.
Is it 1? Negative 1,
Also, you got inverse.
right? Because we have to put the 0 of that goes out front. Okay, it's always gonna be the opposite of that operation every time, the number that goes out front, right? So it's a negative 1. So now we got it all set up, and now we can do that real simple synthetic division process. So I drop the 1, then what?
Multiply.
Multiply by what's out front always, right? So 1 times negative 1 is negative 1.
Subtract or add?
I add, don't I? So I do the opposite of long division. Long division I subtract, synthetic division I add.
You add it.
So I get 3. So what goes here?
Negative 3.
Negative 3 when I multiply, I
3
add
again.
those.
Negative 3 again. And then
0.
0, okay, so there's no remainder. So that means there is no fraction part this time. There's no remainder. All I get is just a polynomial part of my answer.
1 plus 3 plus 3.
So it's
Okay, so yeah, but
x
what do those
squared
mean?
X
Oh.
plus x, no, x
Plus
cubed,
3x.
is it not? Oh, yeah, x.
So
That's
Right.
x squared.
Okay, how do you
plus
know?
3x.
So let's talk about that. How do I know what powers of x go where?
The one right
The
before the
first
remainder,
three.
you just go from there.
There we go. So that's the constant. So this one must be my number.
Just
That's my
x.
x coefficient.
That's x squared.
X squared. Okay.
Good job, Blake.
So then we get our answer is just 1x squared, which I would write as x squared. Next I get a positive 3, so plus 3x. And I get another positive 3, so plus 3.
And what
Bang.
you do, there's the answer.
And that's it.
Like, oh.
All right, one more quick one like that. So how about this guy?
You may use synthetic division.
I can use synthetic division, right? Good. So what are my what's my coefficient row look like?
We need 2.
3, 0, negative 7.
Oh.
Good. I need a 0 because I'm missing the x term, right?
And then a 5 on the outside.
Good. Outside we get a positive 5. Good. And then I just do the process.
15,
So I bring down, what do I do first?
you gotta bring down 3.
Bring the 3 down.
Then you go to 15.
Okay, times 5 is 15.
Just 15.
Plus 0 is 15. So what is that?
75,
75. 15 times 5 is 75.
68.
So I add those up and I get positive 68. Okay, so what's that telling me then?
Yeah.
What's the polynomial part of my answer?
3x plus 15
Good.
over 68.
The constant, so coefficient of x.
Nope.
Okay,
Plus 68 over x minus 5.
There's
Oh,
my
yeah,
coefficient.
yeah, yeah.
So this looks like
3x
3x plus 15
plus
plus
68 over x minus
Good, Keegan. Good.
68 over
X minus 5.
x minus 5. Piece of cake, right? No big deal. Okay, last one is just a trick, right? Here's where we could use synthetic division for something else. It says use synthetic division, but we called this synthetic substitution.
I remember learning this.
So this is our remainder theorem stuff, right? All this said was if I want to do something that I've been doing all year, if I want to evaluate a function, so I'm plugging in a value for x, I could just plug it in directly, right? Or I could use it. If I do that, though, I'm going to have to take exponents. I'm going to have to exponentiate. Instead, I could just use synthetic division and get the answer that way. So help me set this up then. What's my synthetic division bracket going to look like here?
So 2
It's
on
like
the
about
outside.
3.
You don't change it, do you? So it's just 2?
Exactly. Okay, so whatever number I'm inputting into the
But you gotta know if
function
there's a remainder.
Multiply by.
But
is
you
the
gotta know
number
if
that goes outside.
If it's the remainder,
3,
it's the reciprocal
I'm
of
a big
that.
kid.
Okay.
I like a man.
So
X minus 2. Like a man, Mr. Bus.
Doesn't make any sense.
Does that make sense?
You missed the button.
okay, so what's the coefficient row look like?
3,
3,
11,
6,
6,
0.
Oh, no. Which means it was like.
What she said.
Okay.
and then
And
square root of negative 5.
where is, so if I want the answer to this, I want to know what is the value of f of x when I plug in 2? F of 2, in other words. Where am I gonna get the answer from my synthetic process?
It would be the box.
Okay, whatever's in the remainder box
The remainder of the box.
is the answer, right? So that's all we gotta do. So if we drop the 3 down, 3 times 2 is 6, plus negative 11 is
Nope.
negative 5. Times 2 is negative 10, plus 6 is
Negative 4.
negative 4, times 2 is negative 8. Add those up and what do I get?
Negative 13.
Negative 13.
That's all you gotta put in.
And so that's my answer.
How about it?
Good. All right.
That's so much faster.
Go to work. It is. It's faster. Go to work.
Shut up!
Around the board, or we?
The man doesn't miss the bus.